In this module, we'll delve into the intricacies of CAT ratings and their significance in multimeter operations. CAT ratings, or overvoltage installation categories, classify power distribution systems based on their resilience against high-energy transients. As we progress from CAT 1 to CAT 4, we encounter environments with increasing power and potent energy transients. Let's put theory into practice using our CAT environment-controlled simulation cabinet. On the table, you'll find a CAT 2 rated multimeter. Pick up the multimeter and place it inside the testing cabinet. Now, set the multimeter to a voltage function and connect the test leads to the corresponding input jacks. Connect the probes to the live and the ground testing outputs. Safety first, let's close the cabinet and turn on the power. Alright, now that the power is on, observe the reading on the display. You can see that it measures voltage just fine. Now let's increase the environment to CAT 2 level using the rotary switch on the front panel. Notice the stability of the meter? But what happens if we push its limits? Rotate the knob to a higher CAT level. Watch closely as we push this multimeter beyond its limits. That explosion demonstrates the risks of using a multimeter beyond its rated environment. Always ensure you're using the right tool for the job. Before we proceed, let's turn the power off first. Next, we have a dual-rated multimeter with CAT 3 1000V and CAT 4 600V ratings. Place it inside the cabinet and set it to the voltage function. Our dual-rated multimeter is nearly set for action. Now grab the dual-rated test leads. These unique leads offer adjustable length test tips, allowing you to tailor the probe tip length to your measurement environment's needs. It's crucial to remember that with the insulator extended, the meter lead is rated for CAT 3 up to 1000 volts and CAT 4 up to 600 volts. However, with the insulator retracted, the meter lead is only rated for CAT 2 circuits, such as outlets and appliances. Maintaining proper insulation and alignment is key for accurate and secure testing. Press the trigger to grab the leads, then use the thumbsticks on your controllers to twist them. This twisting action adjusts the exposed probe tip length from 0.75 inches to 0.16 inches, ensuring precise and safe measurements in various conditions. Once adjusted, connect the test leads to the voltage source outputs. Safety first, let's close the cabinet and turn on the power. Now cycle through the CAT levels from the lowest level 1 to the highest level 4. Works just fine. Let's increase the CAT level. No issues so far. Let's set the cabinet to CAT 4 level. Still stable. As observed, this multimeter can safely operate in environments up to its highest CAT rating. Always ensure your multimeter's rating aligns with the environment. Now let's explore another phenomenon that electricians must be vigilant about: transients. These are brief, intense voltage spikes that can occur unpredictably when working with energized equipment. They represent a significant risk, especially when measuring live systems. While the setup might seem exposed, it's designed to replicate real-world scenarios, like taking voltage measurements on a busbar system for motor controls. Being aware and prepared for these transients is crucial for safety. Now, let's proceed. Open the cabinet enclosure and reconnect the test probes for phase-to-phase voltage measurement at the exposed fuse terminals. Close the cabinet, turn the power on, and set the CAT 3 level. For this test, we've set our simulation to CAT 3 1000 volts and applied a 480 volts three-phase voltage. As you can see, the multimeter is currently measuring 480 volts across 2 phases. Now let's initiate the transient by pushing the corresponding button on the front panel. Take a step back and observe. The transient will occur shortly. That was fast and intense, but let's take advantage of our virtual environment and replay the incident in slow motion. When the transient occurs, currents as high as thousands of amps can flow for several microseconds. At this current level, the tips of test leads superheat and probe tips start to burn away, drawing an arc from the contact point to the probe tip. The technician sees a bright blue arc flash and at the same time the bang from the arc exploding inside the meter. If 2 arcs join due to the close proximity of the test probes, one large arc is formed, providing a low impedance path from one electrical phase to another, causing a phase-to-phase fault. The result is an arc blast. Let's explore other potentially hazardous situations. One common mistake is measuring voltage with the test leads connected to the amps input instead of the volts input. Let's see what happens when we do this. But first, turn off the power, open the cabinet, and reconnect the red test lead from the volts input jack to an amps input jack. Even though the multimeter is signaling an error, let's proceed and measure the phase-to-phase voltage in a Cat3 environment. Close the cabinet and turn the power on. When the power is turned on, the multimeter with inappropriately connected test leads creates a short circuit. This is because the multimeter is meant to be put in series with the circuit. A low impedance shunt inside the multimeter provides a path for the current to flow. As you can see, the multimeter is now providing a direct path for the current to flow from one electrical phase to another. This is a dangerous situation and can lead to severe consequences. And as the current continues to flow unchecked, it causes an arc blast inside the multimeter, leading to its catastrophic failure. Now that we've explored the intricacies of transients and the importance of proper multimeter usage, let's see how well you've grasped the information from this experience. Ready? Move back to the workbench and complete a short quiz. A transient is a change in the electrical system. Which of these options best describes it? CAT ratings are essential for the safe operation of a multimeter. Why is it so important to understand and respect these ratings? Transients can have a dramatic effect on your equipment. What happens to the multimeter when a transient occurs during a measurement? Incorrectly connecting the test leads can be a dangerous mistake. What happens when one lead is in the COM jack and the other in the amps jack while measuring voltage? Transients can lead to various outcomes. Which of these is not a result of a transient? Congratulations, you've successfully completed Lesson 2